So this is an overview of our Micro 810 PLC trainer. You should have all picked yours up by now. You can see on this side we have the Micro 810 PLC. It's from their Micro 800 series. It already has a USB adapter connected to it. In industry, you would use that typically just when you're programming and setting it up. Then you'd unplug that and leave the device out in the field. On the left side we have a black box that's just containing some I/O that we use for testing. A row of push buttons across the top, a toggle switch, and then 3 indicator lamps. Looking at the top side, you can see there's a fuse. Shouldn't have any issue with that. We haven't blown one yet, but it's there in case something happens. And this is where we plug in our power supply. Across the top of the PLC here are the inputs to the PLC. First two are DC power to supply the processor itself. Then we have a group of 4 inputs with a common, and then another 4 inputs with a common. And in this case, this red normally closed push button is connected to input 0, the toggle switch is connected to input 1, and then these 2 normally open push buttons, green and black, are connected to inputs 4 and 5. On the output side, we have 3 relay controlled outputs. We'll talk more about different types of outputs later in the course. But in this case, the one with the green wire is running the green lamp, yellow is the orange lamp, and red is the red lamp, outputs 0 through 2. So that's kind of a quick introduction to what's here. We have an LCD display on it that can display information, and then also has some push buttons that we can use for control later on. So let's go ahead and plug in our power supply and watch it power up for the first time. Now let's go over what the information we can learn from the LCD display in this default. So right now it's showing you that its first 2 inputs it considers as being on. That could be either they have a voltage supplied to them or a ground provided to them, depending on whether we're syncing or sourcing those inputs. And we'll talk more about that later. But in this case, if you watch as I push the red push button, that first input is changing state. As I toggle, the second input is changing state. So when you see that black box filled, that means it sees it as that device being on or true. Similarly for the green push button, you can see that the 5th input and the black push button, the 6th input, are going true when I actuate them. On the output side, you can see when I hit the green push button, the green lamp turns on, it's connected to output 0. Black push button is turning on the orange one, and the red push button is turning on the red lamp unless the toggle switch is pushed. So that's just a quick program I put in there for me to be able to verify everything was working before I sent them out to you. So if you haven't already, why don't you grab your PLC trainer and connect the power supply to it. Once it powers up and you have a screen looking like this, go ahead and run through the push buttons just to see how the inputs behave when you activate inputs and outputs. Once you've done that, we'll move on now to connecting to the PLC using Connect Components Workbench. And actually, before we connect to the PLC and the computer, I want to think a little bit more about the logic that we saw demonstrated in that really basic program that came in your PLC. Just to review how we look at ladder logic diagrams. So reviewing back to MEC 133, or as a quick overview for those of you who may not be as familiar with them, a ladder diagram is a way to document control side of an electrical control circuit. It doesn't have power devices on it. It only has input devices and control output devices. So outputs on a control ladder diagram might be things like relay coils, indicator lights, coils for motor starters, things like that. It's not going to have the actual motors themselves or solenoids or things like that. This is going to be lower control voltages. So this might be like a 24 volt DC supply represented by these rails. So if it's a 24 volt control source, and then typically this would be the positive rail and this would be the negative rail. Or if it was AC, they would just each be line 1 and neutral or something like that. So if we think back to how our little trainer just behaved, let's talk about the green lamp first. So in that case, we had a push button that when we toggled the push button, it lit our green indicator lamp. So that would be a representation of the logic behind that. A normally open push button, right, the bars above the contacts. So when we press that, it provided a path from positive through the circuit, energized our green light, and then electrons would flow back to the power supply. So this is how we would have done that when we were wiring things as discrete devices. Just clarifying, this is not how the PLC is doing it, but the way of representing it will be very similar. So we're reviewing that. Okay, the next one let's do was the orange light. So in that case, we also had a normally open push button. So pretty repetitive compared to the one just before. So this was we call this PB1, maybe was the green. Call this one PB2, is black, if we wanted to provide some documentation. Now the next rung would be a little more complicated in there, in that we had a normally closed, we could tell from looking at the wiring, so we had a normally closed push button, and then we had a toggle switch, which I'll just represent that as like a knife switch here, that was controlling whether the red lamp was energized. So this one, there was two different inputs that were controlling what happened. So PB3, we might call this one, and that was red. And this was the toggle. So that would be a way to create the functionality that we saw for our inputs controlling our outputs in a discrete control diagram. So that's the ladder logic portion. So just keep that in mind as we move forward today and start to see how that program is represented inside the PLC. It will look very similar in structure to what we just did here on paper. Okay, so we're going to go ahead and connect to the PLC for the first time now. So I'm going to go ahead and start up Connected Components Workbench, which you've all installed. And I'm going to go a little bit slower way for this first connection than we might necessarily need to, just to show you kind of some tools that are available to you. So you'll notice if you're looking at my PLC, I don't have my USB cable connected yet. And that's because I want to show you something about the communication drivers. So when you start up Connected Components Workbench, it'll come to a screen that looks like this. And we'll go over a lot more in detail the program components in the future. But right now I just want you to go up to the Communications bar and click on Configure Drivers. And it'll take a minute because it's going to start another little program here that is typically called RS Links. It's a separate program that controls the communication to Allen Bradley products. And it takes a minute to start up. It'll pop up in a separate window. So it looks like this. And again, if you continue on with PLCs, you'll become familiar with all these different types of drivers. Right now, there are some Ethernet IP drivers running because I have Ethernet, obviously, interfaces active on my computer. What I'm going to do now is while this window's open, I'm going to plug my USB cable into the PLC and my computer and watch what happens. So that's one of the nice things about USB is it recognizes that new devices are connected, and you can see now it's added another driver called 12-point Micro 810. And that's just saying that it recognized I plugged in a PLC and it can see it. So I'm just going to close this window, but that's helpful, a helpful way to see what communication options are available to you at any time. So I'll close that. So now we're back to the initial startup window of Connected Components Workbench. And at this point, I'm going to click on Discover. And I could have done this just straight away if I had my PLC already connected via USB, but I just wanted to use that kind of different way of getting to it to show you how you can check and see what communications protocols are currently running. So I'm going to click Discover, and you can go ahead and do this too as long as you've got your USB cable connected. And now here are those various drivers that I saw through that previous way of looking at communication drivers. And you know from that as well that the one I want is this Micro 810. So I'm going to click on the plus sign, select the one that I'm curious about, and say OK. And what it's doing now is it's going out and starting to talk to the PLC, and it's looking to see what program is in it. So it's basically uploading the program out of the PLC. So this is how you're going to, for the first time, see what actual logic is running in the PLC and how the PLC is configured. And as you saw there, we now say upload succeeded. And for the first part of that upload, it was giving us a graphical representation of the PLC, but it didn't show the LCD. It just showed a blank cover. And then as it finished uploading the configuration information for the PLC, it added the representation of this LCD here because it realized that that was installed. So if you're coming up to a PLC for the first time, or even if you're going to be programming a PLC, it's always best to upload the program out of the PLC, one, so you can make a backup copy of it in case you need to go back to that at some point in the future. But two, by doing that, it already has all the configuration information from the PLC already in it. You can start from scratch, and we'll go over that process in another lesson. But this is a quick way to not have to do all the configuration about the hardware on a PLC. And on one of these little micro PLCs, it's not hard to configure it. But if you had a card-based system that had several racks, it could be 10, 15, 20 cards in it, it can take quite a bit more time to set that up. So that's a time-saving choice there. Okay, so now if we look at our main window here, if you look on the left at this tree, you can see we have one device configured, our Micro 810. So if we expand that tree, the first page is the one that we have open here. This is kind of an overview of the controller, its current status, and its configuration. So right now it says it's in the run mode. If we scroll down here, it tells us what part number it is, and you can look at different settings in here about how it's configured. I won't go through all those right now because they are things more advanced for later, but we will notice, like down here, if we look at LCD, it's saying, yep, I've got an LCD module attached to me, and there's different ways you can configure the LCD. But what we're really curious about today, this is our first PLC program, is what program is actually going on in here. So again, coming back over to the tree, you can see there's a Programs tab, and in this case there's one program in it, and it's labeled Program 2. So if I double click on Program 2, it's opening the window, and this is the ladder diagram for the logic that's running in the computer, or in the PLC, sorry. And as you can see, it looks very similar to what we just drew out on paper in its layout and in style of information. So on this first rung, so we call a rung the horizontal lines there, we have a normally open contact. It looks like a normally open relay contact. It can be any contact, anything could be hooked up to that. It could be a push button, a limit switch, a float switch. We use this normally open contact. Another way to think about that contact is the idea examine if closed or examine if true. It means consider this instruction true when the input is activated. So as opposed to this next one down, which would be examine if open or examine if false. It kind of represents a normally closed contact, right? And you'll notice that on this rung 1, the contact is blue, and on rung 2, the description of it is red. And that has to do with whether that contact is active right now or not. We'll go over that more in a minute. On our output side, we have what looks like a relay coil. In this case, that just means it's an energized output. And I've labeled them previously to be green lamp, red lamp, and orange lamp. So that's our structure there. If you look up at the top, since we uploaded this program and haven't disconnected since uploading it, it shows us that we're connected. And you can see that this is green up here, it says connected. That's also represented by the fact that the background here is tan colored, and these connections are blue or orange. That's showing that I'm online, showing what's actually happening in the controller right now. So if right now I come over and press the green push button on my PLC, watch what happens on the screen. So that contact became red, meaning it's now considered true, and that continued across the rung, and there were no other inputs controlling that. So then it turned on the green light. So now it shows me both my input and my output are activated. Let's look at the next rung. You can see here that the label for the red push button is red, and that's because it is energized, because it was a normally closed contact. But that type of instruction I have put there is what we call examine if open. So in this case, the input is energized, but the instruction is false, because I'm saying only consider this true if the input is not energized, just the opposite of up above. So if I push the red push button now, you will see that the label, the actual address, went blue. And if you look at the screen over here on the PLC, that input is no longer have voltage on it. So it's not true on a hardware sense, which makes the instruction true. And that's something that it's okay if your mind's not wrapped around it yet. It will be in not too long. This is just getting into the great flexibility of what a PLC can do. And you can see, so now that instruction is true, but my light isn't on because I have two instructions in series. So this says not only does input 0 have to be not energized, input 1 does need to be energized. So now if I turn the toggle switch as well, now that rung is true and the red lamp is on. Okay, so and then last, just same thing with the black one. Okay, so that's a way I can watch what's happening in the PLC in real time. But to actually program it, I don't want to do that while it's running. So I do my programming when I'm offline or disconnected from it. So I come up here and go, just click on it, and now I am disconnected. And so you can see, you can just tell at a glance without even looking up here, my background's now white, my rungs are black. Quick, easy way to tell I am no longer online. So now that you've uploaded the program that came in your PLC, let's save that somewhere so that you always have that as a reference. And if you want to, if you're ever worried, maybe you're not sure if one of your inputs or outputs is working, you could always re-download this program to your PLC and just verify everything's working correctly. So I have my program here. It gave it a default name of Project 39, but I'm going to go up to File and save the project as. And it automatically creates this folder, that location. I'm going to go ahead and call this example 1. Actually, let's call this something that we all call it the same thing. Let's say first IO program. Okay, and then I will say I'm fine saving it in that folder there. So you'll see it's under users, my name, documents, CCW first program. So we're going to go look at that in a minute so that you can see what's inside that actual folder, because you'll see it's got a name for the program, but it's also creating a folder for that. And so actually, to make that a little easier to find in the future, I'm just going to stick that on my desktop for right now and say that's okay. And you can see, so now it's got a folder on my desktop called First IO Program. Okay, save that. And you can see up here now it's called First IO Program. I'm also going to change the name of my program within that. So that is basically my project, this First IO Program. Down here, I'm going to just slow double click, or you can right click on it to rename, and let's call that whatever your name is. So I'm going to call it John Day 1. So go ahead and do that. Rename that program to be whatever your name is, Day 1. And then we're going to take a screenshot of it, because this is one of your assessments for today, that you were able to upload the program. And actually, just to verify that you're looking at the right program, I want the screenshot to be of the actual ladder logic program. So before you take your screenshot, double click on it like that, so that we're on the page that shows the ladder diagram, but also make sure I can see your name over here so that I know you've edited. So the program name is First I/O program. The program within that should be called whatever your name is, Day 1, and then take a screenshot of that. So I'm going to use my snipping app and do a new snip of that, and then save that. I'll just save it in that same folder. Say whatever your name is, John Day 1. And you're going to upload that as part of the assessment for today. Okay, so you've uploaded, you've connected, you've saved your project. Now we're going to do our first editing of ladder logic. And to do that, we're just, like I said, we could start from scratch with a whole new one, and we will do that soon. But for today, while we're trying to minimize new things we're doing, what I want you to do is, again, go to File, Save Project As, and now instead of First I/O program, we're going to call it whatever your name is. So I'll say John, and then we'll say 3PB. So whatever your name is, and then 3PB. Because we're going to make our basic first program is going to require us to push all of the push buttons we have to light up a lamp. So that'll work. So I'm going to say OK, and now it's the exact same ladder logic, just a different project. So it's basically created a copy for me. So if I double click on the ladder logic, you'll see it's still called John Day 1. So let's change that now to just be 3PB. Oh, it won't let me start with the letter. Okay, so we'll rename that using the letters, 3PB. Okay, and now I'm just going to come in here. I'm going to select the rung. You can either right click and go delete, or I'm selecting and just hitting the delete key. So I'm going to delete all my rungs. It'll always leave just one in there. And now we're going to edit that so that it requires us to push all 3 push buttons. So we know I said we're going to turn on a lamp. So if you look across the top here, these are what we call our favorite instructions. So if you need to add a rung, you can drag that down here. If you need to add a normally open contact, or direct they call it, or examine if closed, that's there. This can create us a branch. Then there's all kinds of different instructions. For today, we're staying real simple. We're just going to use either normally open or normally closed contacts and this direct output. That's basically, think of it as a control relay coil. So let's do this in a couple stages. So first, I'm just going to bring down the examine if closed contact. And as soon as I dropped that, it brought up this variable selector saying, okay, I see you want me to evaluate whether something is true or not. What do you want me to look at? And it came to local variables, and we'll talk more about those. Those can be where we create tags or data variables that don't have to be tied to hardware. But for today, we're starting really simple. So we do want to use a hardware bit. So if you move your way across here, you'll see there's I/O. And there's already some names in here because I had set those up for that first I/O program. If this was a brand new program, you wouldn't have any of this information in this column to know what's hooked up to these different inputs. But in this case, we do. So just to give you an idea of how this column is broken down for I/O, you can see they all are I/O. That makes pretty good sense, inputs and outputs. The next kind of grouping there is EM, and that stands for embedded. That means that on this device, these inputs and outputs are part of the the initial box. So if you think about, we've talked about some PLCs are card based, you may have card numbers there, but in this case they're all embedded in the processor. The next breakdown there is either DO for digital output or DI for digital input. So we could have analog inputs or analog outputs as well, but these are on this device, we're using these all as digital outputs. So you can see here we have 4 outputs and 8 inputs, and I've already labeled what they are. So let's say we want to use the green push button as our first input. So I select it and then say OK. And that's there. Let's say we're going to control the green lamp. So I'm going to skip to the right side and add an output energize. And again, I'm going to go to I/O, and I want to do the green lamp. So I will say OK. And let's save that. It's always a good idea to save before you download or do anything. So I'm going to save my project. And now we're going to use a couple different buttons that we haven't used yet. Up here near our disconnected one, I could right now try to connect to it. And if I did, it would give me an error saying that, well, let's just show you what happens. If I try to connect to it, it's going to realize, hey, you have a program here that is different than the program in the PLC. So you can see here it says current project content does not match the content in the controller. And that makes sense. So it's saying, do you want to send this project to the controller, or do you want to upload? And I'm just going to cancel because I want to talk you through what I should have done. So what I should do in this case is the first step, I'm going to go back to my ladder logic. The first step, especially when you're new to programming, before you try to download a program to the PLC, is to make sure that you followed all the rules that were appropriate for creating a ladder logic program. And that is done by this little button right here called build. And what that does is it basically compiles your program. It takes this graphical representation and turns it into code that the PLC will actually read. If you think back to when we talked about languages that PLCs can be programmed in, they can be programmed in ladder logic, a graphic language that we're doing here. They can be programmed in structured text, where you write things out like C+, or with function block diagrams. There's a number of different ways. The end result from all those will be the same code, the same actual compiled code going to the PLC. So what build does is make sure you haven't made any mistakes. So let's see here if it's happy with what I have. So I clicked build, and now if you look down in this corner, it's saying, okay, yeah, the build succeeded. I hadn't made any errors. So in theory, I could download it. Let's just go back to the program again. So I come up here and double click on 3PB, or I could have just clicked on it in the tab. Let's get rid of this instruction. So just right click and delete that. So now I have input with no output. And let's try building that and see what it says. And it says it's happy with that too, because sure, I can have an input that's not connected to anything, but if I had done something that violated its rules more, it would give me an error. Basically, like, let's put in an output, but I'm not going to add an address to it. I'm just going to say cancel as far as selecting a variable. So even before I build, you can see it's trying to give me a heads up. Hey, a little warning triangle down here. But let's say I ignore that and try to build and send that. So it gives me an error saying, oh, no, that's not going to work. I'm expecting an output or something for that. And it tells you where. It says on line 1. So I'll close that, go back to my program, and you can right-click at any time and say variable selector. And I'll pick the green lamp. Okay. So once again, I'll check, make sure I didn't make any mistakes. Sorry, it seems repetitive, I'm sure. Okay, it says it built fine, no problems. So I can now use this button next to it. There's 2 here. You can see upload or download. And so it's always have to kind of keep in mind what perspective are you thinking about when you say upload and download. Because typically when we think of downloads, we think we're downloading from the internet to our computer. And that may be the case. In that case, the perspective is from the internet being downloaded to the computer. Here, our perspective is going from the PC to the PLC or vice versa. So when we're sending a program to the PLC, that is downloading. So kind of the opposite of when you're downloading a file from the internet. Download in this case means leaving the PC, not coming to the PC. So to send it to the PLC, we download. So I'm going to click on download. And it's going to ask me, hey, right now I'm running a program. Do you want me to stop running that program so you can change it? And I say yes. And you can also, if you look down here at the PLC screen, you can see it's telling me it's in run mode. And as soon as I click on yes, if you're looking at the face of the PLC, that's going to change to program. So it does. See right there, it's changing to program. And also up in this corner, you can see a box that's flashing telling you that it's communicating with the PC. You can also see that in this info box down here, and that was a pretty short program, so it's pretty much you're going to go pretty quick, but you can see down here it's giving status updates in the very bottom window. And now it's telling me, okay, I downloaded it, do you want me to go back into run mode? And so again, if you watch as I say yes, now the PLC's back in run mode. So before, when I hit the red button, you may remember it turned on a red lamp. Now it's not, because I don't have that logic in there anymore. Black button's not doing anything, red button doesn't do anything, toggle doesn't do anything. But hopefully if I did things right, when I press the green push button, the green lamp comes on, and it does. So step one is going well. Okay, so I'm going to disconnect again because I don't want to edit while I'm connected. And what I said our goal actually was for me to have to push all three push buttons. So for the black push button, that's pretty easy. We'll just bring down another examine if closed. I'm looking at that and I'm going to say black push button. Okay. And just to demonstrate the concept, I'm going to put in another examine if closed instruction and put the red push button in there. And now if you've been kind of grasping what I've been talking about, you'll know that that's a mistake. I need to use a different type of instruction there, since the inputs that are wired, hardwire-wise, to the green and black, those are normally open, and the red is normally closed. But we're just going to kind of use this as an example. So I'm going to check the build again. It says that's great, so I'm going to go ahead and download it. It's going to ask me the same question again. Do I stop reading to do that, or stop running? Yep. And switch back to run, yes. So now it'll show us our program. And we're online with it. So I'm going to hit the green push button, and no lamp yet. I'm going to hit the black push button, and you can see the light came on right away. I'm not pushing all three yet. I don't know if you can see this. I'm not pushing the red push button, but it shows as true, and that comes back to it's because it's a normally closed contact. So if what I want to have happen is me have to push all three push buttons for this to be true, I need to flip the state or the type of instruction that's watching the red push button. So I'll go ahead and disconnect and change this. I can delete that and add the examine if open instruction and go to I/O, red push button, and say OK. So now, just walking through before we actually connect to it, I need to see a voltage on input 4, a voltage on input 5, and no voltage on input 0 to illuminate the green lamp. So I'll go ahead and build it. It says I did fine, no errors, and then I will download. And yes. And yes. Okay, so here, now before I press any push buttons, you see now this is really helpful when anytime you're troubleshooting a PLC or whatnot, being sure you understand how the I/O is represented. So you can see that the labels for input 4 and input 5 are blue. That means they are not energized at the moment. And the instruction below it is an examine if closed or an examine if energized. So both of those are blue. The label for input 0 is red, meaning it is energized, but the instruction is an examine if open. So that is not true. So watch what happens when I hit just the red push button. So if you look at the screen of the PLC, the hardware input no longer has a voltage on it. So its tag turned blue, but that made the instruction now true. I hope that makes sense. Okay, so I'm going to hit the next through the green push button and finally the black push button. And you can see while I'm holding all three push buttons down, the green light is now on. Okay, so we've completed the program edits we wanted to make. That's a good first start for you. You've now uploaded a program, you've saved a program, you've used that as a template to create a new ladder program. And so now we're going to disconnect. Anytime you're going to close a program or change configuration, it's always best to not be connected to the PLC when you do so. So I'm going to disconnect. And looking at the screen now, I should have the project should be your name 3B, and the program should be 3B. And right here I want you to take another screenshot because this is going to be the second deliverable showing me that you created a program of your own. And actually, I take that back. If you've already disconnected, I'm sorry, but let's go ahead and reconnect. You don't have to re-download it, just click on disconnected because I want to see that you're online with it, because that tells me not only did you edit a program, but you got your new program downloaded to the PLC. So with your screen looking like this, it's connected so you can see the status of the inputs. Organizer, the project name should be your name 3PB. The actual program should be 3PB. Now take a snip of that. So we'll do another screen capture, whatever tool you're using. I'll do it on mine and create an image of this, everything here. And I will call that, and this is not first IO program, this one is John 3PB. So call it whatever your name is, 3PB, and then the graphics file. Okay, so you now have two images that show me that you first uploaded a program and then you downloaded a program. So what we're going to do next is just a practice of how to create a zip folder or a compressed format. Let's close Connected Components Workbench. So again, I'm going to disconnect before I close it, just so I don't mess anything up with my PLC, then close the program. Okay, now I am going to open File Explorer, and we're going to go look at those programs. So here is the folder that I had, and you can see it created two different folders inside that, plus these number of files. And if it's a more complicated program, it can have many more folders and files as well. So anytime I ask you to send me a program, an example of your program, you're really sending me a bunch of files. And to have that work cleanly in my MHCC, you need to zip all of those into one package. So if I was asking you to send me this controller, a copy of this program so that I could download it to my PLC, we'd go back up one level to this John 3PB, and if you right click on that, there's a couple different options on how you can do it. I happen to have 7-zip installed so I could send it to an archive, but pretty much everybody will have, it's not showing up because it's too far down the list. Can you guys see send to and then a compressed zipped folder? I'm not sure if that's showing up there. Let me scroll up just a little more. So send to compressed zip folder. So I'm going to, if I did that, it's creating the zip folder, just the same title's fine. And now that folder includes all those other files and you can upload it. That's one way to do it. So I also, what we're going to do for today though, is I actually don't want your project folder. I want those two images. So to practice on my desktop, I'm just going to create a new folder. And we're going to call it, let's call it, it won't stick it where you guys can see it. Let me move my window over here. So rename that to whatever your name is. So I'll just say John Zip Practice. So that's my folder. And now in File Explorer, I want to find those two images that I had. So desktop, so John 3B. So there's one of them. I mistyped mine. Mine says John 2BP. Let's just change that to 3. Okay, so I'm going to put that into that zip folder, and then I'm going to look for the other one under first IO, and there's John Day 1. So now if we go and look at that folder, this is John Zip Practice, it has the two images in it. So I come back up one level, so I'm seeing that folder, and again I'll right click on it and say send to, sorry, let's keep scrolling off. What I clicked on was send to zip, and now it's there. So now in MyMHCC you would upload that file right there. Okay, that's it for today. So just to refresh, your deliverable and your grade today is based on uploading one zipped folder that has two images in it. One image is showing that you uploaded your program successfully, as described in the video. The other image shows that you then used that program, the default program, as a template to create the 3 push button version of the program. So just like as I described in the videos, the different times I wanted those screen captures, take them, put them in a zip folder, and upload that to MyMHCC. I hope that all makes sense. If not, please send me emails, and I'll see you all on Wednesday. Thank you.